All right, now we're going to look at the other type of circuit with resistors. We're going to talk about parallel circuits. So the second way is called parallel, where there's a kind of parallel path for each of the currents. So instead of all of the current going through all of them, here we have the same voltage, but different paths for the current. And so they have all these separate points here. So here's a look at a very simple parallel circuit. You have a battery providing current. Let's say you've added it up and 6 amps of current come out of the battery. It gets to this point, let's say it's a 6 volt 6 amp battery. So it's giving energy, and then each of these drops from 2 to 7, from 3 to 6, from 4 to 5, the current has to choose one of those paths. It kind of splits up in between those things. It's kind of like different aisles at the grocery store. Generally what happens is the line stays about the same length, and that's the voltage, how much energy it's given. But not every line is the same, and so some will go faster, some will go slower, and that's kind of the resistance. So what happens is, let's say this 6 amps of current gets to 0.2. Some of it goes through R1. Let's say 1 amp goes through R1. So then you have, from 2 to 3, you have the remaining 5 amps. And then let's say 2 amps goes through R2. And then you get the remaining 3 amps going through R3. Just coming up with fairly simple numbers here. So you have 1 amp, 2 amps, and 3 amps. So the 6 amps of current that were coming out of the battery split up between those two. And the way they split up is the idea that in this parallel circuit, the currents are different because they're different resistors. But the voltage will be the same, because if you look along this line, there's no difference between these points here. There's nothing to kind of use up the energy. So if this was at a voltage of positive 6 volts, all these points would be at the same electric potential. And then you would drop the same amount. So it's like you'd have different slides of different angles, but they all go from the same height to the same depth. Like if you've been to different places where they have some really steep slides or really long loopy slides, something like that, you may have different slopes, but you always get to the same place. So in a parallel circuit, you can do the same thing. We can do the equivalent resistance. But the math of this is a little bit trickier, because instead of the current being the same, the voltage is the same for a parallel circuit. So each one has a different current. And I'm going to call that I1, I2, I3, I4, I5, however many individual pieces there. So, but the total current has to equal the sum of all those, because it comes from somewhere. It doesn't. So the equivalent current is how much current goes through the battery. The battery pumps the current through, and then it splits up through all those different paths. So if we look at it, resistance is still voltage over current, but now you have all those things in the denominator, and that's the problem. You can't just split up the denominator. So what we have to do is we have to flip it. We have to take the inverse. So 1 over the equivalent resistance is current over voltage, current over voltage, and current over voltage. If you look at that, voltage is just current times resistance again. It's just Ohm's law. And so you get this, to find the equivalent resistance of a parallel circuit, you have to do the inverse of all of those individual pieces. And we'll look at that a little bit more as we go forward. So you have to add the reciprocals. So you get to do fractions, or just do it in your calculator, which I'll show you a little bit later. And then take the reciprocal of it. So it gets a little bit complicated, but you'll see that it's once you apply those same simple rules of what the resistance is, what Ohm's law tells you about individual resistors, you're able to figure out most of what's going on. But then it gets really complicated, and we'll talk about this a little bit after break, is what happens when you have circuits that are a combination of series and parallel. If you look at it, you can kind of see, well, all of the current goes through here, and then it splits up. So what I would have to do is treat R2 and R3 as a parallel circuit, and then replace that with a single resistance, the equivalent resistance, and then R1 would be in series with whatever combination you had there. So you have to be a little bit. There's a little bit of logic that goes into those problems.